Welcome to Shit You Wish Your Building Did, the must-watch show for transforming your commercial spaces into smart buildings. Today, we're diving into the world of building data and unified namespace with Brahm from Mix Consultancy, exploring why it might be a solution to commercial buildings' data integration problems. Why are data integration problems in commercial buildings so persistent, and how can we fix them? Join us for this insightful conversation with Brahm, and remember to like, subscribe, and hit the notification bell to stay updated with our latest episodes. Ready to transform your building with smart technology? Let's jump right in. Brahm, welcome to the podcast. Really pleased to have you here today.
Yes, excellent. Thanks, Jim. Thanks for inviting me along.
Of course. Tell us a bit about yourself. Tell us a little bit more about your work at MIX.
Sure. So I'm a smart building consultant here at MX Consultancy, based out in London. We work predominantly on commercial real estate built environment projects, whether it's fit out type works, retrofit works, or on new builds.
Mm-hmm. Yeah, cool. And you mentioned to me before you have a background in industrial automation as well.
Yeah, so my roots lie within industrial automation. So as a whippersnapper, I qualified in or did training in electrical and electronic engineering as a generic degree, and then since then, or the early part of my career, worked in industrial automation. So that's traditional PLC type controls. Mm-hmm. Being the person in the control panels with a screwdriver and a laptop, coding, and then just as time's gone by, progressed into the design side of things. The wind blew me in a direction, then into building management systems and energy management systems. Mm-hmm. So probably for the past 15 years or so, I've been integrating as an engineer. And then the past 5 years, I've been working on solution architecture, more the design side of things, and overseeing the deployment and enterprise systems, so global systems.
Great. All of which is going to be important for this conversation, because we're going to come on to some more industrial automation things in a bit. But I wanted first to kind of frame this, and I've in the introduction, I've talked about this kind of traditional data integration problem in commercial buildings. So, but I want to hear from you, what you think is a good description of that problem and why it is so persistent.
Yeah, so it's it's an evolutionary issue, I would say. Traditionally, when we come to data integration in buildings, there's the layer cake model that's sort of been followed, and that's the traditional method that's always sort of been there, and it's born out of just what we needed to achieve from the various systems. So, the sensor talked to the controller talked to the head end talked to the platforms further upstream, and historically, that was okay, because historically we were only interested in that little vertical in terms of the platform of the system. Nowadays, as technology progresses, as we are wanting to gain more exposure across the various platforms, that old method of integration is actually holding us back in terms of data integration, right? So when you work your way up through the various layers of integration, you've got a technical debt there. I think that's a good way of describing it, and that you've got to integrate from point to point to point to point. In the end, you've got a lot of commissioning that needs to happen. There's a lot of validation that needs to happen, and inevitably, us as humans, we make mistakes, and things get missed. And then, if you make a mistake at the bottom part of the layer, as it progresses up this layer and it doesn't get caught, then you've got corrupt data that sits at the end, and which we all know is useless.
Mm-hmm. So I've heard you describe it as a spaghetti soup of network penetration and endpoint management and issues, and you mentioned technical debt already.
Yeah. So what seems to be happening now is we've got take for example electricity meter
Hmm.
or a meter. We've got metering system, and that data is valuable to several platforms, and it's also relevant to other sensors within a building. So energy is relevant to occupancy, right? But energy is also relevant to um, the controls of the building. So the heating controls, the ventilation controls, and so forth.
Mm.
So we what seems to be happening now is we'll have an energy management platform and the occupancy platform. And if you want to superimpose, or if you want to start putting the data sets across each other, you've then got to start creating integrations into each platform.
Mm.
So if you then begin to do that for multiple platforms, you then end up with this spaghetti soup. You've got to then create either VPNs, you've then got to create access points within the networks, where you've got baseboard networks, so you've got
Mm.
separated networks. And this is another important aspect here, is the convergence of the various networks. Um, you then end up with this mishmash of access points, and it becomes very hard to manage it. And then equally, if you make a change, say you then make a change in a device in the occupancy side of things,
Mhm.
and it you then have to change that through each layer and through each step.
Right, because I mean APIs are great, right? But there's still like API endpoint management, right? If someone changes something about an API, then that has to be propagated to
That's right.
yeah,
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 yeah. That's it.
yeah. Good. Okay, I think that I think a lot of people listening to this will recognize that. So we've discussed this before. Let's bring in this unified namespace UNS.
Sure.
And again, this is where sort of your experience with industrial automation comes from. This is something that's been born from industrial automation. Could you give us sort of a brief overview of what it is?
Sure. So the challenges that we've got within the built environment around data integration, those challenges have existed for a long time
Mm-hmm.
within the industrial automation space. So there's nothing really new there. Um, Obviously, within the industrial automation space, if you talk factory settings, for example, there's a lot more competition, and there's a lot more drive to be more efficient, because one vehicle manufacturer wants to manufacture their vehicles slightly cheaper than the other one, so that means they get to sell more vehicles. So from that point of view, there's been a lot more necessity in having to have um, um, data integration methods
Mm-hmm.
that are scalable, that avoids the spaghetti soup type integration.
Mm-hmm.
It allows for the convergence of the various networks, and proper convergence, not just connecting networks together and calling it convergence. Um,
Okay, that's interesting.
so,
What would you describe then as proper convergence, as opposed to just stuffing these things together?
well, the reality is you still need to retain a level of isolation, right? You still need to. So if you have a critical application, let's take a power management system that's controlling, you know, fire pumps. This is a critical network. You don't want this network to be hacked,
Mm-hmm.
and the safest way to do it is to keep it separate and isolated. You've got corporate networks that do not want to sit within the BMS realms. You've got landlord networks that can't sit on the corporate networks, right? But we've got valuable data that resides within each of these networks that we want to be able to extract. So then that's something that a unified namespace helps us to do, is by extracting the data, you're converging, but we're still retaining that isolation.
Mm-hmm. Okay.
Yeah. So that's that's really a key part of what the UNS fulfills. And in the industrial automation side, it's the same challenges. You've got your plant networks, you've got corporate networks. They don't want to talk to each other. The IT folks and the OT folks have traditionally always sat within their own camps. Um,
Yeah, that
but
sounds familiar.
ultimately, yeah, but ultimately, to extract this data, we've got to come together. We've got to converge. So the unified namespace is a method of doing it. Not the only
Okay.
method, but it is a method of doing it.
Yeah.
and it's a scalable method as well, which is so
because
it
this is
originated by. Go on.
no, as I said, this is being used extensively within industrial automation already, right? This isn't new,
Well,
particularly new.
the concept of the unified namespace or has been around since 2005, and it was thought of by a chap called Walker Reynolds over in the United States, who sat in a mine, and he had thousands and thousands of sensors, and he had thousands and thousands of various plant that he had to manage, and they were all sitting in their little isolated silos. So he said, and he initially did it on a spreadsheet, on an Excel spreadsheet, actually, was the first sort of iteration of it. So as time's progressed since then, technologies, new platforms have come onto the market, new protocols, not new protocols, but other protocols that are now becoming more prevalent, like, for example, MQTT, are now coming into play. And that concept, that principle has evolved since then, to now being more formulaic as an architecture, and something that we can then take and say, actually, we can apply this within the built environment with success. We've got the architectures that we know work within other industries. How can we now deploy this within the built environment to leverage the same and to extract all of this data, whilst maintaining the challenges that we've got in terms of isolated data siloed networks, the landlord-tenant dichotomy thing going on, right? So it was also born out of the same challenges that we've got,
Right.
So yeah.
Yep. And as I understand it, it's underpinned by MQTT.
Yeah, so MQTT plays quite a big part in this, and that's what's important in terms of the convergence as well. So MQTT is quite handy in the sense that you can just send information out. Obviously, you do need to create some openness within a network to allow you to do that, but you can manage that very closely and very tightly. Okay, so hence MQTT, it really suits this architecture, but there are other ways of doing it. So, for example, via OPC, it can be done via OPC, but then you've got to look at your network. You've got to look at, is the network, have you got how many isolated or segregated networks do you have, and would that be the appropriate method of doing it? So the whole point of the unified namespace is that it's an open architecture. Okay. And it's not a box that you go and buy and screw onto the wall, plug it onto your network and say, I've now got a unified namespace. It's an architecture that you've got to look at your own environment. You've got to look at your own building, and you've got to understand, well, what data do I need to extract from it? And then you've got to begin to design the unified namespace. So it's a concept, right?
Yeah. Yeah. And you mentioned it being an open architecture, and sort of in practice, what does open mean here? Are we talking open source? What are we talking?
So open in the sense of you have got choice of how you deploy the architecture. So the fundamental principles of the architecture is that it's number one, it's edge driven as much as possible. So we want to be able to push as much of the intelligence, if we can, or the compute, if we can, out onto the edge. And by the edge, I mean the sensors, the devices that sit out in the field. If you've got an indoor air quality sensor that's already capable of communicating via MQTT, great. You don't need to have an intermediary box that it's got to communicate with first. You can just have that sensor data published automatically up into a unified namespace, right? So edge as much as you possibly can. Then it's having an IIoT platform, or an IoT platform rather, shall I say. So the IoT platform being something like a Node-RED, or Tritium, for example, also have similar platforms that can be used. but you can choose. You either want to say go for the Node-RED route, or do you want to go into a Trillion route? And of course, others are available.
Sure.
As far as the IoT platform is concerned. Then you need to have data persistence. So the data persistence can be a time series type database, timescale DB. It could be MongoDB. If you already have a Microsoft SQL enterprise subscription within your business, there you go. You can use that as your data persistence. And then you need an ontology.
Right.
Again, the ontology is it's up to you. But the point being is that you've got the building blocks. You've got, here is what you need to achieve the UNS, and within each of the component there are choices. So you then have to go and decide what's best for my organization, what's best for my business, and how can we architect this to suit us individually,
right,
as a builder.
So sounds like there's a lot of flexibility built into it as an architecture.
That's the point. There's rigidity in the sense of, or you have to have an ontology. You have to have some persistence. You have to have an integration type platform, an IoT platform, whether it's OPC, whether it's something like Node-RED, and of course others are available.
Sure.
And to try and push the compute as far out into the edge as we possibly can. And what this then creates as well is a single source of truth. And I think that's the other important thing to note here, is that the unified namespace is a singular source of truth, right? So all the devices, all the platforms would publish their data to the UNS, and multiple consumers can consume the data. So rather than having to have to the indoor air quality sensor, you need to have, say, 3 connections, one to the BMS controls, one to the display screen, wherever it is. You have the indoor air quality sensor publishes its data to the UNS. That's it. And then whatever else needs to consume that data asks for it from the UNS. And then it's then within the UNS that you enforce your ontology and you enforce your naming convention and the governance of that information.
Yeah.
And it can span across isolated networks. So you can have something publish from an isolated network. Obviously, it has to go out through a firewall, but you can limit it so it doesn't go in the other direction. And it just says that input there has changed. Therefore, I'm going to tell the UNS that it's changed. And anything else that needs to know about it, can they know about it?
Yeah. Yeah. Okay. You mentioned data ontologies there. So again, you're also saying it's agnostic. So, for example, if you're already using haystack tagging or brick schema, there's no requirement from this architecture to be specific.
Exactly that. The requirement from the architecture is that you must have an ontology. But if there's already extensive COBE data, for example, now COBE, obviously, as we know, it's not fully encompassing if you want to have semantic tagging, but COBE might be good enough for you, right? So you can utilize that existing ontology. Again, it's just stipulating that you must have an ontology and you must have a means of structuring and naming your data.
Yeah.
And then that's enforced across. So when you then have a provider, so for example, you want to deploy a digital twin, let's say, you can go to your digital twin provider and you say, all right, here's a connection point for you. There's one connection point. Here's the naming convention. Here's the ontology. You've taken the bulk of the integration work away from, and you've already got that there. So all they have to do is just connect to your unified namespace server or environment. They already know exactly what it is how they've got to name things at their end. And it's so much easier to manage. So you've only got that one point that you've got to manage, rather than if it's a digital twin, the digital twin needs to have access to so many different parts of the building and the sensors, right?
Yeah. Yep. Very interesting. So I suppose a question. I mean, as I said, this has come from industrial automation, but I mean, we're talking about something that's, in inverted commas, quite new for buildings, commercial buildings. I mean, where are we? Where are we with it at the moment? I mean, what we're doing here is, I suppose, is trying to give it some attention, right?
Yeah.
Yeah.
So there are actually already, and again, I'm going to come back to the point that the UNS is an architecture.
Mm-hmm.
It's not a product that you buy and you screw on the wall,
Sure.
and it's got to be architected to your own requirements. So we already have some very forward-thinking developers that have started deploying their own sort of, it loosely looks like a UNS architecture, but I think we've got another acronym out there called an IDL, which is an independent data layer.
Uh-huh.
So people might think and say, well, actually, hold on a minute, aren't you just talking about an IDL? Well, an IDL is purely about data storage, and it's about the historic data. Is my interpretation of an IDL, but I'm pretty sure others might see this and go, no, it's not, it's something else. So there's been the IDL type architecture, and I've seen that they've taken that, but they've also then included live sort of live information. That's the thing about a UNS, it's live. It's a snapshot for now.
Right.
And then I've seen some other systems integrators, master systems integrators, they've also thought about a similar method of how do we cross the divide, how do we cross the various silos. So they've begun to develop their own platforms. But you've got to then look at scalability, and it's great what they've done, but can that one singular systems integrator scale up for a global client, for example?
Yeah.
Have they got that capacity in them to do it? So there's already work being done on it. So I wouldn't say it's brand new. I'm not bringing a brand new concept into the equation here. And people are already starting to think about this within the industry.
Yeah.
As you say, I'm trying to just raise awareness around this, and I'm just trying to highlight this and say, well, hey, industry, look, this is a way of solving the data integration piece, and ultimately that's what's going to help us within the smart building environment to suck. We want to suck all this data out as much as we possibly can. Exactly. We already understand the value of superimposing all this data. We already understand what value that the data is going to give us. The problem now is we've got these legacy and historic methods of doing it, which is just not conducive to allow us to get all this data out, right?
Yeah. No, that's a great summary.
Yeah.
I think that it's super interesting. I'll make sure I put some links in the show notes, in the description, where people can find out more. But I guess then, I think that's been a great summary, and if they want more information, I'm sure people will go and look for it. I just think, is there one thing you want someone to take away from this conversation?
Yeah, definitely. So there's a chap within the industrial automation space called Hendrik von Schiele. So I can't lay claim to this saying at all. But what he's got quite a catchy phrase that he uses, but I think it's so relevant. And what he says is, and within this old digital transformation world that we are now in for buildings and digital buildings, I think it's easy to get wowed by tech.
Yeah.
And it's easy to get wowed by the marketing from companies. So he says it quite succinctly, and he says, along the process within your digital transformation, is you've got to think about value. You don't think about the tech. Then you've got to think about people and not the tools. And if you set yourself clear targets from the start, then you're setting yourself up for success when it comes to deploying these platforms.
Yeah, I like that. Very nice. And a good way to finish. Thank you.
Good.
Brahm, thanks very much for today. Appreciate your thoughts.
No, you're very welcome.
And if anyone wants to ask you a question, get hold of you, what's the best way to do that?
Certainly, you can tag me in the comments, for sure, if that's possible. hop onto our website. By all means, you can find me on LinkedIn, send me a message.
Great. I'm sure they will do that. So thanks again. Thanks everyone for listening. And we'll be back next month with a new episode.